Good morning to our grade 7 students. I am teacher Jonard Rogingan, mathematics teacher of Bagao National School of Arts and Trades, your teacher in Mathematics 7. I am here to help you in answering your self-learning material. In the previous session, you have learned how to illustrate well-defined sets. Now, you will learn about subsets, universal sets, null sets, and cardinality of sets under the most essential competency for quarter 1, week 1. Illustrate well-defined sets, subsets, universal sets, null set, cardinality of sets, union and intersections of sets, and the difference of two sets. For our learning target, at the end of this learning session, you should be able to illustrate subsets, universal sets, null set, and the cardinality of sets. The beauty of the universe. In the beginning, God created the heavens and the earth. Now, the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And God said, "Let there be light," and there was light. God saw that the light was good, and He separated the light from the darkness. God called the light day, and the darkness He called night. And there was evening, and there was morning, the first day. Now, let's get started. The universe is something that pretty much contains everything you can think of. So does that mean the universal set is a set that contains everything? Yes, it does, but it should be suitable. So, what is a universal set? The universal set is the set that contains all objects under consideration. Based from the definition of the universal set, teacher Liling asked her students to give an example of universal sets. Von Von's answer was, set U contains the set of whole numbers. What are the elements of the universal set? Set of whole numbers. What are they? We have 0, 1, 2, 3, 4, and so on, so forth. And Sharon's answer was, set U contains the set of all letters of the English alphabet. So, what are the elements of our universal set? All letters of the English alphabet. What are they? We have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now, it's your turn. Can you name the universal set of the set having the elements of Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday? Yes, you are correct. Very good. Set U contains the set of days of the week. Now, I want you to consider this scenario. You are in some serious mood to have ice cream and you have 3 options to choose from: taro white cheese, avocado macchiato, and mango dark chocolate. Let's just refer to them as T for taro white cheese, A for avocado macchiato, M for mango dark chocolate. Let's say you can have only one ice cream at a time. It means you have either taro white cheese, avocado macchiato, or mango dark chocolate. What if you feel like having 2 at a time? What are the different possibilities? You can have taho white cheese and avocado macchiato, or taho white cheese and mango dark chocolate, or avocado macchiato, and mango dark chocolate. In each of these scenarios, 3 sets were formed. Each of these sets is a different possibility. But what if you feel like having all 3 together? There exists only one possibility in this case, a combination of taro white cheese, avocado macchiato, and mango dark chocolate. And here's one scenario nobody wants to be in. If you are unwell and the doctor has advised you against having any ice cream, in this case, what we have is an empty set. You have none of this. Don't forget the original set we were looking at. The original set was taro white cheese, avocado macchiato, and mango dark chocolate. This is the set of all kinds of ice cream we could choose from. The most important thing we need to understand is that all the sets on the right are part of this main set. Yes, each set here is part of this set. And in mathematics, we say that each set is a subset of the main set. It's a little easier to visualize these sets to be a part of the main set. T is a part of TAM, TA is a part of TAM, or AM is a part of TAM. But we should also know that the empty set is also the subset of the entire set. And every set is also a subset of itself. Let's define subsets mathematically. Given any 2 sets A and B, if every element in A is also an element in B, then A is a subset of B. The symbol is, and you can read that as A is a subset of B. Let's consider the following examples. Number 1. Given set R having an elements of 1 and 2, list all the possible subsets of R. Since the set is having 2 elements, which is 1 and 2, let's start grouping the elements of the set R 2 at a time. There exists only one possibility in this case. We have 1 and 2. And take note that every set is a subset of itself. Then, group the elements of set R 1 at a time. There exists only 2 possibilities in this case. We have 1 and 2. And we all know that empty set is also a subset of every set. So we have the empty set. Let's consider this example number 2. Given set O having an elements of red, blue, yellow, list all the possible subsets of O. Since the set is having 3 elements, which is red, blue, yellow, let's start grouping the elements of the set O 3 at a time. Remember that every set is a subset of itself. So, there exists only one possibility in this case. We have red, blue, and yellow. Next is group the elements of set O 2 at a time. There exists only 3 possibilities in this case. We have red and blue, red and yellow, and blue and yellow. Then group the elements of set O 1 element at a time. There exists only 3 possibilities in this case. We have red, blue, and yellow. And we all know that empty set is also a subset of every set. So we have empty set. Let's consider example number 3. Given set S having an elements of 3, 6, 9, and 12, list all the possible subsets of S. Since the set is having 4 elements, which is 3, 6, 9, and 12, let's start grouping the elements of the set 4 at a time. Note that every set is a subset of itself, so there exists only one possibility in this case. We have 3, 6, 9, 12. Then, group the elements of the set 3 at a time. There exists only 4 possibilities. We have 3, 6, 9, or 3, 6, 12, or 3, 9, 12, and we have 6, 9, 12. Next is group the elements of set S 2 at a time. There exists only 6 possibilities in this case. We have 3 and 6, 3 and 9, 3 and 12, 6 and 9, 6 and 12, and 9 and 12. Then, group the elements of set S 1 element at a time. There exists only 4 possibilities in this case. We have 3, 6, 9, and 12. Remember that empty set is also a subset of every set. Therefore, empty set is a subset of set S. And for our next example, given set E whose elements are M, A, T, H, list all the possible subsets of E. Since the set is having 4 elements, which is M, A, T, H, let's start grouping the elements of set E 4 at a time. There exists only one possibility in this case. Remember that a set is a subset of itself. So we have M, A, T, H. Then, group the elements of set E 3 at a time. There exists 4 possibilities. We have M, A, T, or we have M, A, H, or we have MTH, and we have ATH. Next is group the elements of set E 2 at a time. There exists only 6 possibilities in this case. We have M and A, M and T, M and H, A and T, A and H, and T and H. And for our last example, let's consider set G whose elements are 0, 2, 4, 6, and 8. List all the possible subsets of G. Since the set is having 5 elements, let's start grouping the elements of the set G 5 at a time. There exists only one possibility in this case, itself, whose elements are 0, 2, 4, 6, and 8. Next is group the elements of the set G 4 at a time. There exists only 5 possibilities in this case. We have 0, 2, 4, 6, 0, 2, 4, 8, 0, 2, 6, 8, 0, 4, 6, 8, and 2, 4, 6, 8. Then, group the elements of set G 3 at a time. There exists only 10 possibilities. We have 0 to 4, 0 to 6, 0 to 8, 0 for 6, 0 for 8, 0, 6, 8, 2, 4, 6, 2, 4, 8, 2, 6, 8, and 4, 6, 8. Next is group the elements of set G 2 at a time. There exists only 10 possibilities in this case. We have 02, 04, 06, 08, 24, 2 and 6, 2 and 8, 4 and 6, 4 and 8, and 6 and 8. Then, group the elements of set G one element at a time. There exists only 5 possibilities in this case. We have 0, 2, 4, 6, and 8. Always remember that empty set is also a subset of every set. Therefore, empty set is also a subset of set G. Okay, here is an interesting question. Write the set of crying trees. Yes, you've read the question correctly. Does a tree have any eyes? Well, I do not know of any such trees. So the answer is none. And to represent this set, we draw brace and write nothing inside it. Such sets are called empty sets. Another way to represent such sets is using this symbol. It is also referred to a null set, means none or void or empty. So, what is an empty set? An empty set is a set with no element. It is also called null set. The symbol for empty set is this one, or you can use this symbol. What about this? Set T, wherein the elements are counting numbers between 1 and 2. Is this an empty set? Yes, very good, that's correct. We all know that the elements of counting numbers are 1, 2, 3, and so forth. And we do not have counting numbers that is between 1 and 2. Therefore, T is an empty set. The more questions you look at, the more interesting this topic gets. Now, listen to the next question very carefully. Set I is the set of months with 35 days. Is this an empty set? Yes, you are correct. This is an example of empty set. Why? Because the months of January, December, March, October, May, July, and August are 31 days, while February 28 or 29 days, and November, April, September, and June are 30 days. But wait, we have no months that are 35 days in it. So, set I is an empty set. What about this? Set M is the set of cars with 60 doors. Is this a null set? Yes, you are correct. That is an example of a null set because there is no such cars with 60 doors. So we can write it as your set M is an empty set or a null set. What about this? Set B is a set of flying castle. Is this an empty set? Yes, that is an empty set. Very good. Why? Because there is no such thing as flying castles. Therefore, we can say that set B is empty set or a null set. Take note that a zero with braces or a null set with braces are not empty sets. Only braces or this symbol represent empty sets. Given set K whose elements are 1, 2, 3, and 4. The number of elements of set K is equal to 4. Set D is the set of vowels in the English alphabet whose elements are A, E, I, O, U. And the number of elements of set D is equal to 5. The word number of elements is also called cardinal number. So we can write that the number of elements of set K which is equal to 4 as the cardinal number of set K is equal to 4 and the cardinal number of set D is equal to 5. And the word cardinality in mathematics is referred to as size. So we can say that the cardinality of set K is less than the cardinality of set D. Another important terms about set is the cardinality of sets. The cardinal number of A is the number of elements in set A. For example, given set A whose elements are 1, 3, 5, and 7, the cardinality is equal to 4 because set A contains 4 elements. Now, let's answer this question. Set R is the set of letters in the word difficulty. Find the cardinality of set R. By listing the elements of set R, we have V, I, F, C, U, L, T, and Y. Therefore, the cardinality of set R is equal to 8 because set R contains 8 elements. How about this? Set M is the set of odd numbers between 1 and 3. Find the cardinality of set M. Odd numbers are 1, 3, 5, 7, 9, and so on and so forth. As you can see, there is no odd numbers between 1 and 3. Therefore, the cardinality of set M is equal to 0. And for our last example, set E is the set of letters in the word survivor. Find the cardinality of set E. By listing method, the elements of set E are S, U, R, V, I, and O. Therefore, the cardinality of E is equal to 6 because set E consists of 6 elements. And now, get your learning material and answer what's in, what's new on page 7, what's more, what I have learned on page 11, and what I can do on page 12. Write your answer on your activity notebook and you may check your answers by using the answer key on page 21 to 23. Thank you for tuning in. I hope you have fun learning experience with me. Again, I'm Teacher Jonard Ragingan of Bagao National School of Arts and Trades. We will continue discussing in the next series of episodes more topics about sets. Hoping to see you again till next time. God bless.